Okay, I like this question because it's a mixture of linear motion and free fall. The rocket is launched upwards with a initial velocity of 35. Its acceleration is 5 meters per second per second. It means it started off with a linear motion because it has this uniform acceleration, 5 meters per second per second. Suddenly, the engine breaks down, but it will not automatically fall down. It will goes up and travel acceleration due to gravity. So this point onwards, it is a free fall motion. Even though it's moving upwards, it's still considered as free fall motion. Okay, travel until it reaches its maximum point that it can reach, and then it goes back down. So for part A, the speed of the rocket at height 20 kilometer. So it asks you the speed here. This range is under linear motion. Let's do SUVAT analysis. Okay. So as we have 20 kilometer, I'm going to convert it to meter. And you have U, which is 35 there. We want to find the V. And the A is given here. Don't have any information regarding time. Therefore, out of these three, most suitable one is the one without T. That's the second one. Okay, V we want to find. U is equals to 35, 2, 5, and 20 kilometers. So V equals to 448.58 meters per second. Okay, this is the velocity at this point where it starts to break down. So for part B, it asks you the maximum height achieved by the rocket. It means it asks you the height from the ground to the maximum point that the rocket achieved. You already have information regarding this height, therefore all you need to find is this h prime here. So basically, to find h maximum is h plus h prime. I'm going to label the h prime as sy so that you know you are trying to find s. So we need to find sy. Let's do SUVAT analysis. So sy is what we're trying to find. In part A, we already find the velocity at this point. So the v, the velocity that you find in part A, will become the initial for part B here. Okay, so uy will use that value that we find in part A. So Vy is equals to 0. Why? Because at maximum point, Vy equals to 0. Ay is negative 9.81. Time, we don't have any information. Doing the SUVAT analysis, you know that we don't have time, so don't use the equation with time. We use the second one, which is Vs. Remember to label everything with the component that you are using. Free fall only consists of y component. Substitute. Uy is this. Therefore, the value of sy is okay. But we are not done yet because it asks for height maximum. Maximum is simply 20,000 plus sy here for h prime 6.07 6.07 meter, or you can write it down as 30.26 kilometer. For part C, it asks you the time of flight. It simply means the time from it launch and then up to the maximum point and then go back down to the ground. So the time of flight for the rocket. In order to do so, you cannot find the time from here to here. You need to separate them. Okay, Why? Because time taken for the rocket to move from here to here, it accelerates with a 5 meter per second. But the moment it breaks down, the acceleration will become negative 9.81. So the difference value in A means that you cannot find the time simultaneously. Okay, you need to do it separately. So I'm going to find the first time. I'm going to label it with T1. You know, from the moment it breaks down and goes to up here and then go back down, it's free fall motion. Therefore, we can find the time taken for it to goes up and goes down. So that's T2. Well, you can actually find the time from here to here, and then you can find another time from here to here. You need to calculate 3 times. But if you do the time from here back to the ground, you only need to do 1 time. In order to find the total flight, you need to do T1 and T2. This is T1, this is T2. Okay, so for T1, do SUVAT analysis. For this part, information that you know is S. The value is positive because the final point is here, the initial point is here. Therefore, final is above initial, positive. U is 35. V is at this point, which is this value. A is 5. We need to find the time. So based on these, actually can use this equation and this equation. Cannot use this one because you don't have time in it. I'm going to choose this one since this is much simpler. So V equals to U plus AT. V here is 4. U is 35, A is 5, and the time. So the time taken, 82.72 seconds. Okay, that's the time T1. Now we want to find T2. As I mentioned before, you can find this time first and then find this one. But it's much easier if you find the time from here up to here. So let's do the SUVAT analysis. Okay, so since you are doing free fall, please write down the component. So free fall only have Y component, so label Y. Okay, look closely. T2 is the time to move from here up and then goes back down. Therefore, value of SY, this part, 20 kilometer. Because initial is here, final is here, therefore the height is this part only. But the value is negative because the final position is below the initial position. You need to put the negative sign there. So be very careful regarding the value for SY. So UY, okay, initial point is here, therefore the value of the velocity is this one. Vy is here. We don't have any information regarding Vy. Ay is negative 9.81. Okay, time is what we need to find. Choose the most appropriate equation, the one without V, therefore the third one. S equals to T squared. So please label the Y component. Substitute 20 kilometer. So UY is 448.58 T plus half T squared. You will get T equal 124.27 seconds, and the other value is 32.8 second negative. Since time is a scalar, since time don't have negative value, so the T2 is equal to 124.27. therefore the time of flight, you add up T1 and T2, 27 equals to 206.99 seconds.